All right, so theorem 2.8 has a bunch of properties of inverse matrices. And one of them is that the inverse of the inverse equals the matrix itself. Now, in this theorem, we are to assume that A is invertible. So let's see, how would we proceed? So we know how to check to see if two matrices are inverses of each other. So if we multiply the two matrices together, we should get the identity, and we have to multiply them both ways so that we can be sure. So then we have to reinterpret this and read this some other way. So we're going to say proof. I'm going to say I need to show that the inverse of the inverse gives me back the matrix itself. So this is almost trivial, but let's see how we can reason through it. This inverse, we can write it in words. So we can say this means, the sentence means the inverse of A inverse, right? So the inverse of, I'm writing that in words, A inverse is equal to A. So that's what I'm going to check. So I have to check this. Okay, so how do I check that the inverse of a matrix is this other matrix? Well, I have to multiply the two matrices together. So this matrix, I don't know if I should call it the inverse of, I could call it matrix B. So the inverse of this matrix is equal to A. So I don't have to, of course, but I have to think of this guy as some other matrix. Okay, so then what do I have to check? I have to check that the inverse of A times this guy equals the identity. Well, does that happen? Does the inverse of A equals, times A equals A? Well, yes, because we are to assume that this A inverse is the inverse of A. Okay, so number two, I am to check that A times this new guy is equal the identity. Well, does that happen? Yes, it does, because that's the definition of what it means for A inverse. So that means that the inverse of this guy is exactly what I hoped it would be. So the inverse of A inverse is